The purpose of a turbocharger is to compress the air flowing into the diesel engine, squeezing more air into a cylinder. The engine burns air and fuel to create mechanical power. The more air and fuel it can burn, the more powerful it is. A turbocharger comprises a turbine and a compressor connected by a shaft supported on a bearing system. It is driven by the waste energy from the exhaust gas. The exhaust gas is guided into the turbocharger by the turbine housing. The energy in the exhaust gas turns the turbine. Once the gas has passed through the wheel, it leaves the turbine housing via the exhaust outlet area. Exhaust gas temperatures are up to 760 degrees Celsius, which means that high resistance materials are needed in the turbine wheel and housings. The speed and load of the engine determines how fast the turbine wheel spins. If the engine is in idle mode, the wheel will be spinning at minimal speed. As more gas passes through the turbine housing, the faster the turbine wheel rotates. At full speed, the turbine wheel can rotate at over 150,000 rotations per minute. The compressor wheel is connected to the turbine by a forged steel shaft. As the turbine wheel spins, the shaft powers the compressor wheel. Air is drawn into the compressor housing through the wheel and is compressed as the blades spin at a high velocity. The housing is designed to convert the high-velocity, low-pressure airstream into a low-velocity, high-pressure airstream at the outlet through a process called diffusion. Air enters the compressor at atmospheric temperature. However, it leaves the compressor cover at around 200 degrees Celsius. As air temperature increases, its density decreases, thus even more air can be forced into the engine if the air is cooled after the compressor stage. This is called intercooling or aftercooling and is achieved by cooling the air either with water or air.